Hey guys, this is Captain Hook with your daily dose of physics problem solving. Today we're going to deal with a problem dealing with displacement and velocity. This problem you can actually see in its entirety below the video here, but I'll go ahead and run through it real quick once just so you guys know what's going on. We have a squirrel that's running along a fence. A random bystander who's curious about the squirrel velocities has shrewdly observed at which fence post the squirrel is located at every 1 second interval. After the squirrel has run away, the bystander measures the spacing between two adjacent fence posts to be 5 feet. And we'll just assume that every single two fence posts are 5 feet apart. All right, we see that after 1 second, the squirrel's got 5 feet away. After 2 seconds, he's 15 feet away. 3 seconds, he's 25. 4 seconds, he's 35 feet away. 5 seconds, he's 55. And at 6 seconds, he's 60 feet away, and we can't really see him past then. All right, so our first question, our first part for this question, says, based on the observations, estimate the squirrel's velocity between each of the measurements. So sort of like its instantaneous velocity. And then what we're going to do is we're going to start out with a chart where we know the displacement of the squirrel, aka how far away it is. So we get our displacement, which is in feet. We also have the time for the squirrel to get to that time in seconds. And we're just going to make a little chart. Okay. So we know time is every second up to 6 seconds. So we're going to start at 0 seconds, go to 1 second, 2 seconds, 3 seconds, 4 seconds, 5, and 6. Okay. Now, obviously at 0 seconds, he's gone 0 feet away. At 1 second, we said he's gone 5 feet away. At 2 seconds, he's gone 15 feet in total. At 3 seconds, he's 25 feet in total. At 4 seconds, he's 35. At 5 seconds, he's 55. And at 6 seconds, he's made it to 60 feet. So this is sort of just what we already know. Now, what are we trying to figure out? We're trying to figure out his instantaneous velocity for each of these intervals. Okay? So our velocity in this case, because we're dealing with feet and seconds, is going to be feet per second. Okay, so we're just sort of adding to our chart. This is what we're looking for part 1. Now, when you're finding a velocity, you have to have a starting and an ending point. So we have 7 different times, 7 different distances or displacements. So when we find velocity, it's actually, velocity itself is displacement over time. So that's all we're going to do. Now we can find that by doing its final distance, or final displacement, minus its initial displacement, dividing by its final time, minus its initial time, for each one of these. Okay? So for our first interval, which is between 0 and 1 seconds, we're just going to do 5 feet minus 0 feet over 1 second minus 0 seconds, which is going to give us, well, 5 minus 0 is 5, 1 minus 0 is 1, 5 feet per second. Sort of bubble this off here so it's off to the side. So there's our first interval. So that's sort of that interval there. Now we gotta do our second interval. Same idea. Our final distance is 15 feet minus our 5 feet over our distances that change in time, 2 seconds minus 1 second. Well, 2 minus 1 is, again, 1 second on the bottom. 15 minus 5 is 10. We give 10 divided by 1, still gives us 10 feet per second in this case. Now, if you notice, because every interval is 1 second, when we do our distance, our change in time on the bottom, it's always going to be 1 second. So for the rest of these, I'm just going to immediately put 1 second on the bottom. So we are between 2 and 3 now. So 3 minus 2 again is going to give us 1 second on the bottom. But it's 25 feet at 3 seconds minus 15. So 25 feet minus 15 feet. Again, 25 minus 15 is going to give us 10, so we still get 10 feet per second. Now we're going to do between 3 seconds and 4 seconds. Again, our bottom is going to be 1 second. 35 feet minus 25 is going to give us, again, 10, so 10 feet per second once more. Okay, starting to see a pattern here. Won't always work out with the same numbers, but in this case it seems to be doing pretty good. So now we've done between 3 and 4. We got to do between 4 and 5. So between 4 and 5 again, our bottom is going to be 1 second because 5 seconds minus 4. Now we got 55 feet minus 35 feet. Okay, so that's going to give us 55 minus 35 is 20 feet over our 1 second, so that's 20 feet per second. We got one more to go. So our 5 to 6 second interval, again we do 6 seconds minus 5 seconds, gives us our 1 second. And now we got 60 feet is how far he's made it, minus our 55 feet. In that case, with 60 minus 55 is going to give us 5 feet per second. So all of these numbers right here are his instantaneous velocities for each one of those intervals. So that's our first part of the problem. All right. Part number 2 says by taking the average of all of these, we want to estimate the squirrel's average velocity for the entire 6 seconds. So to do that, first we got to think about what average velocity is. If he was to be going at the same speed or the same velocity, how it would take it in the same amount of time, it would take him the same distance. So to find your average velocity, so our average velocity, V average, is just the sum of all the individual velocities divided by how many velocities there are. Okay. Now we just said, if we look back at our other page, that we have 1, 2, 3, 4, 5, 6 velocities. So the bottom of this is just going to be 6, because that's how many velocities we have. And now we just have to sum. We have to add all these up. So we have 5 feet per second plus 10 feet per second plus 10 feet per second, another 10 feet per second, 20 feet per second, and 5 more feet per second on that. Over the total number. So if we add all that up, our average velocity, go on the top, 5 and 10 is 15, 25, 35, 55, and 60. So 60 feet per second over 6 different velocities. If we divide that out, our average velocity is going to be 10 feet per second, which we probably could have guessed just looking at the numbers, but that's our part 2. All right. Part 3 asks, do we need to actually have all 6 measurements in order to determine the squirrel's average velocity, to determine that? Or do you think you can do it with only 2? So this is part 2. Part 3 down here. Well, if we know that the squirrel started at 0, right, its initial, and ends up 60 feet away 6 seconds later, no matter how fast he was going in those intervals in between, if we know the ending point, or his ending displacement, his starting displacement, his ending time, or how long it took him to get there, we can use just the beginning and end to figure out what his average velocity is. So in this case, what we can do is, if we want to find the average velocity without using all of that data, we could just use the very initial point, which was 0 seconds, and just do our velocity equation again. So we have 0 seconds is where he started, and he started at 0 feet. He ended at 60 feet, and he ended 6 seconds later. So again, just like our velocity equation here, we're just using it again for just the beginning and ending point. Well, if we do this, we get 60 feet minus 0 feet gives us 60 feet. We also get 6 seconds minus 0 seconds gives us 6 seconds. And if we actually divide that out, we get our average velocity is 10 feet per second. So if you notice, it's the exact same number as we found by adding them all up and finding the average of them. Okay. All right, we got one more part for this problem. It just wants us to convert the answer for both of these, since they're the same, we only have to do it once, into proper SI units. Well, if you don't know SI units, we don't use feet, we use meters. Seconds is fine, so we have to convert 10 feet per second into meters per second. So to do that, all we're going to do is we're going to start out with 10 feet per second, and we have to know the conversion for feet per second to, or for feet to meters, and we can know, or we know that 1 meter is approximately 3.281 feet. Okay. So to convert, all we have to do is we make this into a ratio. So 1 meter over 3.281 feet. And since these are the same number, we can just multiply them to our answer. So we multiply that by 1 meter over 3.281 feet. Now if you notice, if there's feet on top of or in the numerator here and the denominator here, so the feet actually are going to cancel each other out. So if we multiply across, we got 10 times 1 is 10, but now we're left with meters, because that's the only thing that's left. And then that's actually 1 second. So we have 1 second times 3.281 feet. That just gives us 3.281, but again the feet disappeared because it got canceled, so 3.281 seconds. And if we put that into our calculator and divide, we get about, again I'm rounding, 3.047 meters per second. But if you notice back here, we only have 2 significant figures, so we're going to have to round that a little bit more to be about 3.0 meters per second. And that gives you the average velocity of that squirrel in SI units, meters per second.